Welcome guys, let's solve another LeetCode daily challenge. Evaluate reverse Polish notation. You are given an array of strings tokens that represents an arithmetic expression in a reverse Polish notation. Evaluate the expression and return an integer that represents the value of the expression. Note that the valid operators are plus, minus, multiplication, and division. Each operand may be an integer or another expression. The division between two integers always truncates toward 0. There won't be any division by 0. The input represents a valid arithmetic expression in a reverse Polish notation. The answer and all the intermediate calculations can be represented in a 32-bit integer. That's also nice because we don't have to care about integer overflow, and we don't have to use some other bigger data types like a long, double, or big integer. That's nice. Before we dive into solving this challenge, let's talk about what is a reverse Polish notation and what other notations are. First of all, the most commonly used notation is infix notation. Infix notation. Let's say that we have two numbers. They are 2 and 5, or two operands, and I'm going to apply the operator of addition, and that's it. This is our expression, 2 plus 5. Let's say that we are going to multiply this expression by another expression, and let's do this. All we need to do is add parentheses and apply multiplication and the value, and that's it. This is very easy to understand. The reason why this notation is the most commonly used is because it's easier for us to perceive using parentheses, because it makes the expression clear to understand. But for computers, for processors, this is not the best notation, because it has extra operators to process. For example, these parentheses, they add more complexity for computers to process, and it requires more space and more time to process, and that's why this is not the best approach. This is not the best approach for computers. And to solve this, another notation was developed by a Polish logician. As the name says, the logician was from Poland, and this is Polish notation. Polish, also known as prefix. They can be used interchangeably. They stand for the same concept. Prefix notation. And let's rewrite the same expression. We have two numbers. As the name says, prefix. The operator precedes its operands. It means the operator comes first. This is it. It means 2 plus 5. And let's say that we are going to multiply this expression by 4. All we need to do is to add the multiplication and the first, because it should precede the operands, and the value we are going to multiply, and that's it. And this is the same expression written using Polish notation. And the third notation is reverse Polish notation. Reverse Polish notation, also known as postfix notation. They can be used interchangeably, and they stand for the same concept, postfix, and that's it. Let's rewrite the same expression using this notation. We have two numbers. We have two operands, 2 and 5. As the name says, the operator comes after the operands. We are going to add, and that's why I'm going to apply the operator of addition, and that's it. 2 plus 5. Also, we are going to multiply this expression by another value, by another operand. All we need to do is add the operand, this is 4, that we are going to multiply, and the operator of multiplication. Since we have discussed about all these notations, let's try to solve the following example and come up with a solution. Let's say that we are given an array of tokens. We have 2, we have 5, we have plus operator, we have 4, and we have multiplication operator. This is our array of tokens. And as you can see, the tokens are given in a reverse Polish notation order, and our goal is to evaluate this expression. And the idea to solve this challenge is pretty simple, and all we need to do is just to iterate from left to right. And while iterating, we need to check all these tokens. If the token is a number, if the is an operand, for example, we need to store in some collection. For example, the first token is 2. This is an operand, and that's why we need to store it in some collection. And whenever we meet some operator, let's say that in this case we have plus, we need to take the last two elements, the last two operands from the collection, and apply this operator, plus operator, to these elements. And in our case, this will be 2 and 5. And the result of this expression we need to put back into the stack. And we do this until the end of this array, until the end of the tokens. Let's do this step one by one. Let's visualize this and make all these steps. The first, and for sorting all these operands, I'm going to use stack, because stack provides operations of delete and put for constant time, and that's why this will be the most optimal collection for this approach. And let's start iterating. The first token is 2, and I'm going to store 2 in the stack. Next we have 5. I'm going to store in the stack. We have 5 and 2 in the stack. And next we have plus operator. And next we need to pop up the last two elements. This will be operand 2, and the second we need to take the second operand as well, and this will be 2, and we need to apply this operator to these two elements, to these two operands. This will be 7. The result is 7, and we need to put this intermediate result back to the stack. Next we'll have a stack with size with only one element. This will be 7, and let's continue iterating over the array of tokens. Next we have 4. We will have 2 elements in the stack. They are 4 and 7. And next we have a multiplication operator. This is our last token. And we need to repeat all the steps that we did right here. We need to take these 2 elements. They are 4 and 7. This is our second operand. This and 4 is our first operand, and we need to apply this operator to these 2 operands, and the result will be 28. And the result of this expression, the result of these tokens is 28. Let's jump into coding this challenge. First of all, I'm going to initialize a stack to store all the operands. Stack of integers, and I'm going to store all the operators that we have in the array of tokens operators. I will initialize as a hash set of operators. They are plus, minus, division, and multiplication. And let's iterate over the tokens. Token in tokens. If token is not in operators, this means that the token is a number. Let's push this number to our stack, token, and continue iterating. Here's a mistake because I need to convert this to integer. And next, by this time we already know that the token is some operator, and we need to perform this action. We need to take the last two elements. We need to pop the last two elements from the stack. Let's do this. Pop. This will be operand 2 and stack pop. Operand 1. That's it. And we need to let's check what kind of token is this. Token. If the token is additional operator, we just add these two operands. Let's repeat this action for the rest of the operands, for multiplication, for division, etc. This will be minus, this will be division, this will be for multiplication, and here is a mistake. And this also we need to handle for the default value, because if we if there is some if there is unnecessary or mistakenly added token, then we are throwing exception. So we throw illegal argument exception. This will be our result, and this this must be illegal argument exception, and we need to store this result, this intermediate result, into the stack. Push result, and all we need to do, by this time this stack will have only one element, and this element will be the result of this function stack pop, and that's it. Let's take this code, let's copy and paste. Let's submit. I hope this works. And as you can see, our solution was accepted, and in terms of runtime it beats 42% of users, and in terms of memory it beats 38% of users. And speaking about the complexity of this approach, in terms of runtime complexity, this will be a linear time, because we are iterating over all these tokens, and the algorithm will be linear. And speaking about the space complexity or memory complexity, this also will be O(n), because we are storing all the operands from this array in the stack. and that's why the space complexity will also be linear. This is the end of this tutorial. I hope you learned something new. If it was useful, please like and subscribe, and see you in the next videos.